Welcome to qnawire.
In this question, it is about how light travels in the optical fiber. So first, um, in an optical fiber, there's a core, and outside that, there's a cladding. So we want to find a critical angle for total internal reflection to take place at the core cladding interface. Then we need to find uh, expression for incident angle, sine of the incident angle, in terms of the refractive indices of the core and cladding. Okay, and then lastly, calculate that critical angle if we are given the refractive indices. Okay, so this question is about total internal reflection, okay, and Snell's law. Okay, so for part A, we want to find the critical angle in the core cladding interface. So we'll be using Snell's law. Okay, so Snell's law says that n1 sine theta 1 equals to n2 sine theta 2. Okay, where 1 is the core, 2 is the cladding. Okay, and then theta 1 is our critical angle, theta 2 is 90 degrees. Okay, we are also given that n1 is 1.465 and 2 is 1.45. Okay, so substitute everything. We have 1.465 sine theta c is equal to 1.45 sine 90 degrees. Okay, so here we can calculate our critical angle. Okay, sine theta c is 1.45 divided by 1.465. So theta c is 81.8 degrees. Okay. Okay, then in part B, we want to show that the sine theta I, which is the incident angle, on this diagram, okay, is equal to square root n1 square minus n2 square. Okay, so let's just redraw the diagram. Okay, so we have the light ray entering the optical fiber, maybe something like this. Okay, theta I, and then it hits the core cladding interface, and then it goes through total internal reflection. Okay, so take this as the normal, and this is theta C, and this is our theta R. Okay, so from this geometry again, theta R plus theta C equals to 90 degrees, right? And then using so this means our theta R is equal to 90 degrees minus theta C. Okay, from Snell's law. Okay, so this is air, and then this is core. Okay, so we have n1 sine n air sine theta I equals to n1 sine theta R. Okay, in this context. Okay, so the refractive index of air is 1, so sine theta I equals to n1 sine 90 degrees minus theta c. Okay, and then this is cosine theta c. Okay, so cosine theta c, okay, if you use the identity using sine square theta c plus cosine square theta c equals to 1. So cosine theta c is 1 minus sine square theta c square root. Okay, so this is what we are going to write. Sine theta I equals to n1 times square root 1 minus sine square theta C. Okay, and then from part A sine theta C is equal to this is what we have last time, right? So sine theta C is actually equal to n2 divided by n1. Okay, so sine theta I is equal to n1 square root 1 minus n2 divided by n1 square, and then you bring the n1 inside, you get n1 square minus n2 square and square root, and shown. Okay, so this is how you do part B. Okay, then in part C, so given okay, n1 equals to 1.465, n2 equals to 1.45, we want to find our theta I. Okay, so sine theta I becomes 1.465 square minus 1.45 square root, and you get 0.209, and then theta I you get 12.1 degrees. Okay, so this is the answer for part C, and that's all.